Now there's going to be many occasions when you have to simplify the division of a fraction which might involve surds. Now for instance, suppose we had the square root of 16 over 5. Now in an earlier tutorial I showed you that this was exactly the same by the division rule as the square root of the top, root 16, over the square root of the bottom, root 5. And the square root of 16 is 4. But the square root of 5 isn't an exact value, so I'll just leave that as root 5. Now we could leave our answers like this, but more often than not we use a method to simplify this further called rationalising the denominator. And by that it means that we don't want to have square roots in the denominator. It's a method that removes square roots from the denominator. And to do this, what we do is we consider a fraction like this as, well in this case 4 over root 5. What we do is we can change the appearance of this by multiplying top and bottom by the same value. And in this case we choose root 5. If I times the top by root 5 and the bottom by root 5, I'm not altering the value of this at all because root 5 over root 5 is 1. And if I times any number by 1 or any fraction by 1, it's not going to change the actual value. What this will do is just change the appearance of 4 over root 5. If we carry on, what we have is 4 times root 5, which is just left as 4 root 5. But on the bottom we have root 5 times root 5. And we should know that that is root 5 squared, which is just simply 5. So 4 root 5 over 5 is the value that is equivalent to 4 over root 5. And we call this, as I said, rationalising. You can always check this on any calculator. If you were to type, say, 4 over root 5 into a calculator that handles surds, what you would actually get out is this answer. Okay, let's try another one. Let's suppose we had to simplify 3 over root 7, for instance. What would you do in a case like this? Well, 3 over root 7 is going to be exactly the same, obviously, as 3 over root 7 times 1. Seems a bit pointless, maybe. But it's how we make that 1. This 1, in this particular example, can be regarded as root 7 over root 7. So I'm going to times top and bottom by root 7. Why do I do that? Well, hopefully you already know, and that is because root 7 times root 7 is just going to be 7, and so that will remove the square root from the bottom. It'll just make it a 7. And in the top we've got 3 times root 7, so that's 3 root 7. Okay, let's try one more, and in this example what I'm going to have is a number in front of my square root. Suppose I had, for instance, 2 over, let's say, 5 root 3. Okay? Then this is going to be exactly the same as 2 over 5 root 3 multiplied by 1. But in this particular case I want to remove that root 3 there. So what I do is just change that 1 to root 3 over root 3. I multiply top and bottom by root 3. What effect does that have? Let's have a look. On the top we've got 2 times root 3, which is 2 root 3. But underneath we have 5 times root 3 times root 3. Root 3 times root 3 is just simply 3. So 5 times 3 is 15. Alright, so rationalising 2 over 5 root 3 becomes this value. And again, check it on any calculator that handles surds. You'll find if you were to type that in, the answer that you would get back would be that value there. Okay, what happens though if we have a fraction that's a little bit more complicated than the ones that we've dealt with here, that have just a single term in the denominator? What happens if we have one that has two terms? So suppose we had, say, 5, for instance, divided by, let's say, 3 minus root 2. What would we do in a situation like this? Well, if we had this, let's just copy it down again. Obviously it's going to be the same as 5 over 3 minus root 2. That seems a bit pointless. It also seems pointless, obviously, saying times by 1. But again, how do we make up a 1 here that's going to be useful, that's going to get rid of this root 2? Well, what we do is, when we've got two terms like this, we switch the sign in the middle. Okay, let's just delete this one here. We switch the sign, so that will be a plus. We take the two terms and we just write them back in. 3 plus root 2, okay, and 3 plus root 2 on the bottom. Okay, this is 1 still, so it's not going to alter the value of our fraction, but it will have the effect, as you'll see in a minute, of changing the appearance. Because if we multiply out the top, we would get 5 times 3, which is 15, plus 5 root 2. But what I'm going to do is just leave that, though, as 5 bracket 3 plus root 2, because I feel it serves no purpose really just to multiply that out. But this is the crucial bit. What we've got is 3 minus root 2 times 3 plus root 2. Let's imagine that they're in brackets. Okay, let's put some brackets around there. So if I'm multiplying them out, I would do 3 times 3, which would be 9. Then 3 times plus root 2, which would be 3 root 2. And then minus root 2 times 3, which is minus 3 root 2. And then minus root 2 times plus root 2 is minus 2. And what we have here is that 3 root 2 minus 3 root 2 disappears. We made that happen because we switched the signs up here. If this had been a plus in another question, make sure you write minuses here. Anyway, returning back to this and just simplifying it, what we have on the top then is 5 bracket 3 plus root 2 all over 9 minus 2, which is 7. And there you have it. This particular fraction has now been rationalized. And again, if you tried it on the calculator, just check that you get that. Okay, so you should be able to rationalize any fraction now that has a single term in the denominator, okay, like these, or two terms in the denominator. When it has two terms, just write those two terms down, and whatever sign you've got here, just change it. So in this example, obviously a minus, change it to a plus. But if that been a plus there, change it to a minus. Okay, so as I say, hopefully you can use these examples to rationalize any fractions that you may encounter.